In this lesson, we will utilize some of the knowledge we acquired in previous ones and do a couple of simple setups with C motion. So you can consider this lesson as a series of mini projects, but I will show you some practical examples of C motion. Now, here we have a simple butterfly and nothing fancy, it's just a simple IK chain that is attached to this butterfly mesh, and this is a simple IK with dynamics enabled, and we covered all that in volume 3, so let's collapse this. And basic idea here is to create cyclic motion for the wings. Before doing anything, we have to determine what do we want to do. So I have this null object which is responsible for rotation of these wings. Now if I hit play, you will see that those wings are actually dynamic due to this IK dynamics here. Now I don't want to manually keyframe all this. This is practically insane, and I'll rather create a simple C motion setup and drive that wing flapping with that. Okay, so let's create our C motion system like this. We will enable it. You can lock this manager and drop this wings source inside the list. And you will immediately see that we need to just drive a simple rotation. And in fact, in this project series, in this lesson, I will try to use the most simplest example with minimum amount of actions, preferably 1 or 2, so you can easily follow and get the grips of these guys. So now we have a pitch rotation that is around this x-axis, and as said in previous lessons, most of the motion in nature is done in either sine wave or arc movement. So if I hit play, nothing will happen because we don't have any value here. So let's try first maybe 45, something like this, and let's even go higher, maybe 65, maybe even a little bit more, maybe 75. So it's a matter of taste. So we have now our butterfly happily flapping the wings, and that's really great. I'm pretty sure some of you will ask how this material is made, and because it's changing colors, and that is due to spherical mapping, not to the material itself. It's just a simple gradient both in color channel and in luminance channel, so nothing fancy, just the matter of material mapping. Now there is one question that will probably be bothering you when you will be dealing with this C motion, and that question is, how do I move this guy? Now, because it is inside C motion, I cannot really move it without destroying it. It's simply either locked, for example this wing source, cannot move it because it's rotation, and everything else is driven by this C motion. Now this is a little bit limiting at the start, but actually there is a simple solution for that. So you can either create an instance of your object, so you can create an instance, and even though you cannot move the master, you can freely move the instance. You can copy them, clone them, or stuff like that. So that is really great stuff. Let me stop this. Now some of you may actually need for this original object to be able to move, even though it is controlled by C motion, but that unfortunately won't work. What you can do is similar to what we did in our motion capturing lesson, is to just constrain this wing source, in this case, to some arbitrary null object or any other object, but nulls are preferred because they're not visible once you are rendering, and you can then drive the rotation on that null object and simply constrain that. So a lot of possibility there. Okay, so let's briefly pause and I will load up another scene. Here we have something a little bit different, and this is one of those toys for kids, and I'm pretty sure it is called pogo stick, and somebody will probably correct me if I'm wrong, and they use it to jump around and really act crazy with it. Now I thought this was a really good example of hub and target motion. So here we have two hierarchies. Let me show you. And this is a little bit inconvenient trick because it doesn't use any joints. Really use some tricks to rig that via constraints and some simple espresso, but that is not really important in this lesson. What is important is that this guy cannot be moved. Let me show you this. Lower than the line of ground and higher than this guy. So I think that is visible now, and this spring is really behaving as it should. Let me undo all that and let me show you this simple concept of hub and target. So let's load that C-motion guy. Don't forget to enable it, otherwise nothing will happen. And now this main body guy will be my hub object, and this target would actually be the target. So I really named them conveniently, but first let's build the motion with the hub object itself. So if I'm going to move anything up and down, that is this Y axis. So let's add that action. Nothing fancy, really simple. And once again, if you're in doubt, load a sine wave. Let's hit play and let's increase this, maybe something like this. And you see we have a problem because this is not actually how this pogo stick would behave. We have to instruct this target to follow the motion of the hub. So it has to be a target object. Now let's give it a shot and see how that works. And it actually works fine, but we have to restore the original position of the target, and you cannot move it because it is actually locked by this C motion. So let's disable C motion for a moment, simply drag this, it doesn't have to be perfect, enable once again, and hit play, and there you go. This is really interesting, and of course you can make it move in a line or something like that, but this really demonstrates this target options, because it shows how this target inherits the motion of that main hub. So for example, if I hit this guy, we'll simply disable the target, so it will behave differently. Hope that makes sense, and there you go, you have your pogo stick. Let's go to our next example. Here we have something really interesting, and it's a simple worm, and I want to show you how you can create that worm-like motion with C motion. So here we have our master object, which moves the complete worm, which will serve as a hub, and the tail, this null, and this guy that will serve as a target. So both of these guys will be targets, and this guy is also rigged, as you can see, and we'll have some fun with this. So let's create a C motion guy, enable it, and let's lock that manager and drop our hub object inside. And of course you don't have to name this as I do. I just did that so it is a little bit easier to follow. So now I won't be adding any action to my hub. The only thing I will do is instruct it to move in a line. So now it moves like this because this pose guy is telling it which way is forward. So it now instructs our worm that minus z is forward, when in fact we want minus x. Let's give it a shot like this, and This is what I wanted. Let's go back. We will now assign targets to our hub. So let's drop the tail as a child of this hub. Let's also add head as a child of the hub. So let's see what do we have, and how about that? That is absolutely great. Now this works because of these guys are not in the same phase. If I change them to 0, watch what happens. And that is the idea behind those phase options. So by changing the phase, you can completely change the motion. Let me undo that once again, and that is absolutely great. Without Z motion, this would be really difficult to create. So here you can create simple verbs with this nice technique. Just one hub and two targets. Okay, let's go to our next example. In this project, we are going to take a look at how we can integrate C motion with some simple dynamics and some simple expressor to our advantage. And here we have seemingly one object, but it is actually made of 3 parts, and they are all dynamic objects. So if I hit play, you notice that this guy falls down, and that is due to these settings here on this dynamic tag. Now this inner guy, there is this part that is falling, is dynamic, and these two guys, this plane and this outer part, are set to be off. So that means they will respond to dynamic in sense of collisions, but they will not obey forces like gravity. So they will be fixed at their current position. Okay, I hope that makes sense, because this is not a dynamics volume, and I hope you understand the principle. So only this guy, this inner guy, is made dynamic in a sense it will follow the forces. Okay, I hope that makes sense. So let's hit play once again, and it simply collides with the ground. Now let's actually create a material just to be distinguished more easily in the scene, and let me group all these guys like this. So I will apply that material to that group. So we have now an object that really stands out in the scene. So what it is that I'm trying to achieve here? Well, here my idea for this guy is to really mimic some sort of a laser cut. So part of this object, let's just doodle it, will be cut like this, and once it reaches the end, wherever we define it, maybe here or here, I think this would be a good idea. So it would start cutting from here in this direction, go all the way around, and when it ends, this guy should naturally begin to fall on the ground. Okay, I hope that makes sense and it is easy to understand. Obviously, we have a few problems. The first one is that dynamics kick in immediately after you hit play, so we will naturally have to disable them until certain moment. So for the other part, we have this cut object, which is actually a tube object that will mimic that part. We have a slice option, so we want to use this slice to mimic that cutting action. So first we will do that, and naturally we will use our C motion. So let's drop in a C motion here, enable it. Let's lock this guy to that C motion, and let's lock this guy to nothing so it's not bothering us. And let's drop that cut object inside and create a parameter action for it like this. And that action, if we want to mimic this cutting behavior, has to be this from. Okay, so it should reach 360 degrees. Okay, let's find it. So from the value should be 360, like this. And naturally, because this guy is now all the way up like this, it will reach that maximum value. So we have to go from 0, which is here. Let's actually right click, enable snap, and pull this guy to 0. So now if we do a time warp like this is what will happen. So our guy will be doing the action that it should, but the problem is this guy falls too early, and this action should happen a little bit differently. And when I say differently, I mean straight line, because currently this is a little bit of easing action, and actually don't want that. I want completely linear flat line. So let me right click here, and under point types, actually I will have to click all the way here, and maybe even then that point types won't be visible. So here I'm choosing a 0 angle / length. So like this. Now this guy is completely flat, so let's give it a shot. So now just disregard this inner part for the moment. Let's actually disable it. So now this guy is acting in a linear fashion. Let's go back. So if I scrub the time like this, once I reach frame 30, this guy will begin its action from the beginning. So it will look like we haven't actually cut anything. So it will reappear at the frame 30. And there is one really good option in the C motion here under basic tab, and there is this auto time. So you can define the start and the stop value of the action, and we want it to run just one time. So we will disable auto time. Let's go back to the beginning, and if our action is 30 frames, I will enter 30 frames here. So 30. Now this is a deliberate mistake, and it will show you that principle where 0 and 30 in this case are the same. So the first and the last frame. So if I hit play, watch what happens. It once again reappeared, and it reappeared because on a frame 29 it's practically completely gone, and on frame 30 it's simply the same value as on the frame 0. So effectively, just as we did in our motion clip, we want to have 29 frames, because 0 is also value. So 0 to 29 has 30 frames. I hope you're still following. So let's hit play now. And this is what happens. We are left with a little guy here, and we don't want that. We can actually counteract that easily by doing something like this. Let's give it a try. And you will see, even though we made everything as we should, our slices from 360 to 360, we still have this little guy, and this is a single flat planar surface, which is a result of a nature of that tube object, that parametric object. Now, to solve these issues we will have to do a simple espresso for a complete system, and let's just first establish exactly what our problems are. So the first problem is that this guy shouldn't be visible after this reaches 360, so it should be gone, and this guy, this cut, should begin to fall after this guy finishes the cut, so not before. Those are our problems, and let's now try to solve them with some simple espresso. And don't worry, this is really simple stuff, so let's add the espresso tag like this, and actually I can get rid of this attribute manager because we will not work with CMotion anymore in this scene. And let's create some space for our espresso so we can have things to be a little bit more clean. Now, whenever you are working with expressions, you want to follow your logic because it is really easy to get lost and tie yourself into some unimportant things. So what I would suggest to people that are not experienced is to create a scenario. So that will help you a lot if you don't have experience in Espresso. So let's actually create a simple scenario. So our cut goes from 0 to 360. That is the first thing. The second thing is that we should hide that little guy once it reaches 360. So we should hide it now. So hide. And the third thing, and the most important for this whole effect, is that dynamics guy on that inner part should be inactive before this value is reached. So if 360 is not, then the dynamics off. Okay, so this is the logic behind programming, because Espresso is a visual programming language, and don't be scared by programming. Programming is a pure logic and really easy. So let's go back. And computers are by nature really stupid, and you have to instruct them for every single step. So you basically have to learn that limited language that computers use, because if you really take a look here, you don't really have much of those nodes. There is maybe 50 of them, even 100. So imagine a complete language that contains only 100 words, and you have to tell a story with 100 words. So that is why programming is also difficult. So you have a limited amount of words, but you have to explain things very well with that limited resource. So let's now speak some Espresso language. Delete this guy. So I will drop my cut object inside and extract that slice value. So this guy, actually I will scale this window all the way up so you can see what I'm accessing. So slice from should be equal, and that is a logical statement. So you will find that node under logic, so equal, and basically instruct to what should be equal. So it should be equal to 360. So let's enter 360 here like this, and let's see the result. Let's actually go from here so you can see the nodes, and unfortunately those menus are really long. So here is the result node. I hope I'm not over complicating things. So let's actually leave it like this. So now if I progress my time, I should be able to see as a result the values of this cut guy. Okay, so let's go, and we have to enable animation refresh, and nothing will happen because we are creating a logical statement. So once we reach 360, we should have a result that would say 1, which means true, but actually that is not happening. So let's control drag this guy and see why is that not happening. So let's drag this guy. Obviously we have some progression here of numbers, but they are not the same as this one. So that is something a little bit disappointing, because you would expect the from value to be stated here. So exactly the same, it should say 360, and this is where some geeky stuff comes along, and internally Sina4D works in radians, which is a little bit difficult to explain, and let's just say it's a different way to express degrees mathematically. The good thing is that you don't have to do anything manually, and if you want to convert some values, if you want to calculate some values, so we want to calculate from radians to degrees, well, we have a node for that, so it's under calculate degree. So we will turn these odd numbers, these guys here, which are radians, to degrees. So let's select our degree node. We will convert from radians to degree. So let's hook these guys up and let's see the result. So it should be now in degrees. So let's verify that like this. So let's go to frame 29 and the values should match, and it is the case. So you can clearly see the values are completely the same. So that's a good thing. Now we have a correct value, and we can continue with our expression. So now when we are 100% sure that we are using correct values, we can simply output that value to this equal node. Now this node will check if inputs are equal. So if inputs are not equal, so 266 is not the same as 360, it will give you a result, and that result will be 0 or false, or 1 or true. So 0 is false, 1 is true. So once you reach frame 29, it will give you a result of 1. Okay, so why is that useful? Well, that is useful because if you drop the dynamics tag of your inner object into this expression, you can actually instruct it to enable or disable itself. So let's find that enabled value of this guy, of this inner guy. So this guy, let's find it here. So dynamics enabled like this, and let's hook this up. With a little bit of luck, once we reach the frame 29, this guy should be enabled because this condition is met. 360 and this 360 simply match, and then this node will say yes, it's true, those guys are matched, and since disabled and enabled are same as false and true, you can use any 0 or 1 value to turn things on or off. Yeah, I hope that makes sense. And let's go back like this, and you will see that once this condition is not met, that dynamic tag simply turns off. So let's see how that works in our laser cut, our imaginary generic example of laser cut. So we hit play, and this is what we get, and this is really cool. So the power of Espresso is unimaginable, and hope I gave you a good insight into it. Now let's not forget that we still have one little problem, so let's scrub the time, and that is this little guy. So why wouldn't we use completely the same logic we have for this guy already? So I want to hide that little piece once these dynamics are enabled. So let me copy this guy. So that is exactly the same guy as this one, and let's find its basic property, which is visible in editor. Now let's scale this a little bit. Now if I connect these two guys, this is what will happen. So it will be enabled until frame 29. Now then it will change to disabled. Okay, I hope that makes sense. So there is a clear difference in this. So effectively, once we hit play, it will disappear at the moment when it should disappear. Okay, I really hope that you are successfully following. So effectively, you could create a beam of light or laser or cutting machine or whatever you want to follow this cut and effectively achieve a cutting effect with a laser or a machine. So that is really useful, and I really hope you enjoyed this one. Now, the following lesson and all these lessons where we did a couple of these little projects are designed to relax you, believe it or not, because the next lesson, when we will take a look at this powerful character component tag, which is really scary, I will need all your concentration to show you how powerful this system is. This is a technical developing system, so let's do just that. Let's tackle that character component in our next lesson.